All right, guys, this is part 2 of the review sheet, which is exponential functions. And this is kind of an overview on how we graph an exponential function, as well as analyze the domain, the range, and what is known as the horizontal asymptote. Now remember, an asymptote is a line where the function approaches but does not touch. The asymptote can be a horizontal asymptote, it can be a vertical asymptote, and we got something called a slant asymptote. That is not going to be focused on in this class. Now, let's look at 2a and 2b. It says, how do you write the parent exponential function? That's pretty straightforward. F of x equals a, which is the base to the power of x, such that your base is greater than 0 and your base does not equal to 1. And it says, how do you write the parent exponential function? Well, that's going to be f of x equals e to the power of x. And that's really it. And remember, e, which is considered the natural number, is approximately 2.71828 rounded to 5 numbers after the decimal. E is an irrational number, so it goes on continuously forever and ever and ever, which is indefinite. Part C says, sketch the function f of x equals 2 to the power of x. After, include the domain, the range, and the horizontal asymptote. So we did this in class, but I'm going to do it again. And I'm going to create a table. And before I continue with this, I'm going to give you a law of exponent that you should know. And that's going to be the negative exponent rule, such that if you have a negative exponent in your numerator, to make the exponent positive, you reciprocate the term. And when you reciprocate the term, the exponent is positive. And the base cannot equal to 0, because if it does, it makes it undefined. And I picked some x values from -2 to +3 to plug into my function. Integers in total. So let's say when x is -2, how do we find the y coordinate? You plug in -2 into the function. That is going to be 2 to the power of -2. To make the exponent positive, we reciprocate that term, which is 1 over 2 squared. And 1 over 2 squared is 1 over 4. Because 2 squared, 2 times 2 is 1/4. And that is the coordinate of -2, 1/4. F of -1. 2 to the negative first power. You make that positive by reciprocating it. That is just going to be 1 over 2 to the first, which is 1/2. So -1, 1/2. And also, I want you guys to remember that 1/4 is equal to 0.25 as a fraction. And 1/2 equals to 0.5 as a fraction. As a decimal, excuse me. Let's find the function evaluated at 0. 2 to the power of 0. Anything to the 0 power is 1. That is the coordinate of 0, 1. Let's find f of 1. Plug 1 into the function. That is going to be 2 to the first, which is 2. Let's find f of 2. Plug 2 into my function. 2 squared is 4. 2, 4. Find f of 3. 2 to the third is 8. The coordinate of 3, 8. And of course, there's more coordinates, but I'm just choosing to use those to make life easier. And now we're going to sketch this graph. So the first coordinate is -2 and 1/4. Let me put that in blue, actually. No, I'll put that in black. -2 and 1/4. That is going to be right here, approximately. Then we have -1 and 1/2. We'll put that right here. The next point is 0, 1. And that's going to go right there. Then we have the point of 1, 2. Which is going to go right there. The point of 2, 4. Which is here. And then the point of 3, 8. Let me zoom out to get 3, 8, which will be right here. Those points right there matches the points that I have here. And then we're going to sketch that function to the best of our abilities. Okay, this first one looks good, so I'm proud that it's going pretty well so far. Let's see, can I get it good down here? You know what? This was a good take. I'm proud of myself for sketching this. And ladies and gentlemen, that is the function f of x equals 2 to the power of x. Now we're going to find the domain, the range, and the horizontal asymptote. Now, the domain for an exponential function, the domain for all exponential functions, and I'm going to write that here in interval notation, is infinite, all real numbers, negative infinity to positive infinity. The range for exponential functions. Now, let's zoom in briefly. Look at the left side of this function. The function here is in closer and closer and closer and closer to the x-axis, but it's not touching and it's not crossing. That is going to be an asymptote. On the x-axis, there is a y value of 0. Every point on the x-axis has a y value of 0. So the function approaches but does not touch that line of y equals 0. Therefore, the lowest y value my function will approach in this case is going to be 0. Analyzing the right part of the function. This function goes up forever and ever and ever. As it goes up forever and ever and ever, the y values will increase forever and ever and ever, which means y will approach positive infinity. That is the range for this function. And last but not least, it asks for the horizontal asymptote, which I'm going to call HA for horizontal asymptote. That is the line y equals 0. Because once again, I explained, the function is approaching the x-axis, which has the y value of 0, but does not touch nor cross in this case. Thus, that is going to be your horizontal asymptote, the equation of y equals 0. And please remember, if it's a horizontal line that is approaching, the equation must be in y in terms of y. So don't just give me 0. You must say y equals 0. Or if it's like y equals 10, if the horizontal asymptote is a horizontal line through the value of 10. So that is how we focus on the basic exponential function, f of x equals 2 to the power of x. I'm going to end this video the way it is. And then in the next video, we're going to be applying some reflections and transformations, such as shifting to an exponential function. All right, guys, I'll see you soon. Take care.